Good morning. My name is Krishna Soni and I am a student of class 12th at PM Shri Kendriya Vidyalaya Andrewsganj. And for this year's Viksit Bharat Buildathlon, we have encountered the problem which is low understanding of concepts by students. And for that purpose, we have made a working model of a handmade DC motor which is going to help the students understand the concepts of electromagnetism and the force law better. So let me explain to you how I made the model and then I will explain you how the motor works. So first of all, I took a couple of 2 by 6 inch wooden blocks and fixed them on top of a 2 by 9 inch plywood. Then I drilled a couple of holes through the plywood, through the wooden blocks, and I fixed a 3/4 inch PVC pipe piece through there, which is going to act as a bearing for the shaft. Then the shaft is made from a half-inch PVC pipe, and I fixed a threaded rod through the shaft, which I have winded copper wire, insulated copper wire, so that it becomes a solenoid for the motor. Then here, right here, we have our commutator and the brushes, which is a copper plate kind of thing, which I have wrapped around the shaft, which is also soldered to the copper wire. And then the brushes are a couple of more copper rods. And right here we have permanent magnets, a couple of them on each side, which are going to produce a strong magnetic field which is permanent. And yeah, let's move on to the mechanism and the principles of the DC motor. So the basic principle behind the DC motor is the Lorentz force law of electromagnetism, which says that when a current carrying conductor is placed in a magnetic field, it will experience a force. So by deriving the formula for torque on a solenoid placed in a magnetic field, we can we get the formula that torque is equal to the magnetic moment of the coil cross product with the magnetic field. So basically, if the if the coil is winded clockwise right here, then the magnetic moment would be upwards, and the magnetic field is from side to side like so. And so if we cross product, if we get the cross product, we can get that the magnetic moment cross with the magnetic field gives us the direction of torque, which is with my thumb. And the direction of torque tells us that the motion of the shaft will be clockwise. So that's how basically the motor works. But one problem arises, that is when the current, if we directly connect the wires to the power source, then right here in the beginning, the direction of the coil is upwards, but when it flips a 180 degrees, the direction of the coil is reversed, which means the torque on it will also be reversed. That means the torque on it is acting in the right direction now. So it would want to spin backwards. So it would kind of go on with the perpetual motion like this, right? And we don't want that. We only want it to go in one direction continuously, like so. So for that we have this mechanism here, which is the commutator. It will flip the current every 180 degree turn, and that is exactly what we want, because every 180 degree turn the direction of the coil is inverting, so we will have to invert the direction of current as well to keep the direction of torque same. So that is how the motor will keep on spinning in one direction only. And this is also explained right here in this beautiful diagram, like so. If the current is going that way and the magnetic field is in north to south direction, we can get the direction of force which is going to be upwards on that piece of wire, and it is going to be downward on this piece of wire, creating a torque. Thank you.